معكم بتول عبد الخالق أحد أعضاء SPE بصرة Student Chapter. عدنا لكم اليوم بكورس جديد بعنوان Drilling Fluid، المقدم من قبل الأستاذ إبراهيم المعمري الذي يعمل كمهندس ميداني أول في شركة KCA Deutag في سلطنة عمان، والذي يمتلك خبرة عملية تتجاوز 7 سنوات في صناعة النفط والغاز والطاقة المتجددة، بالإضافة إلى قيادته لفرق هندسية وتطبيق أعلى معايير السلامة، وامتلاكه لشهادات احترافية IWCF Level 4 ولين 6 سيجما. تتقدم SPE بصرة شابتر بخالص الشكر للحضور بشكل عام وللأستاذ إبراهيم بشكل خاص على قبوله دعوتنا لتنظيم هذا الكورس القيم. بالنسبة لجميع الأسئلة التي سيتم طرحها من قبل الحضور فسيجاب عليها في نهاية هذه المحاضرة، وأيضا سيتم إرسال رابط لمشاركة آرائكم بخصوص هذه المحاضرة. أستاذ إبراهيم، نعتذر على الإطالة، تقدر تتفضل.
السلام عليكم. معكم إبراهيم المعمري. بس I want to make sure everyone can hear me well.
نعم أستاذ، صوتك واضح ونسمع، بس خلي أسد presentation.
Can hear me well. You can. Someone can tell me in raise his hand or something.
We all can hear you well, I think.
I prepared some slides I can share with you going through this really brief lecture about drilling fluid. Can you guys hear me? Can someone turn on his mic and tell me if you can hear me well?
Yeah, yes, sir, we can.
Yeah. Okay, thank you. So, thank you everyone here for the invitation, and we will talk about drilling fluids. I just want to present Can you see my slides here?
Yes, we can.
Yes, we can.
Okay, thank you for your waiting. My name is Ibrahim المعمري. I graduated from my bachelor in chemical engineering from University of Louisiana at Lafayette in the United States. I graduated from my master's from University of West England in Bristol, and I'm doing PhD in Malaysia in University of Uniten. And I did drilling fluid engineering for almost 7 years. So I'm quite in the senior level of doing fluids engineering, working in different parts in Sultanate of Oman, where I am from, and I'm very happy to participate with this organization and tell you more, guys, about fluid engineering. So please, if you have any question, you can stop me anytime. And if you have any doubt about something, you can ask me of the subject or in subject. It's fine. وبتكلم عربي عادي يعني عماني فكنا نتكلم عرب. I will start with this. I prepared some slides for you really quick to tell you more about fluids, as I assume more of you are just are students, right? Am I wrong, or you are like most of you are students, right?
Yes, sir. Most of us are students, but we are also some doctors or other.
Okay, that's good. Okay, that's good. I will tell you about the fluids, which is drilling fluids, and it's very important because throughout drilling operation, there is on the well there are two things: only fluids and drill string. And it's very important to know more about fluids and understand the mechanism of the fluids. So my specialty is focusing on fluids and fluids management as well. It's not very hard subject, but it's very important, and it's required experience if you want to work in the rig site. Usually there are day and night, as drilling operation are 24 hours. There are day and night. They call it mud engineer or fluids engineer, and they are working to maintain and management this fluid. So we will talk about the stage for building a well and drilling fluid overview and waste management and reservoir fluids and completion fluids as well. So if we start from the beginning, the stage for building a well, and if you are doing petroleum engineer, you should know this. You start with exploration, then drilling, completion, and at the end you will have the protection. In all these stages, you will have a drilling fluid and different type of drilling fluids. As you will know, there are fluids used for drilling, there are fluids used for completion, there are fluids used as a backer fluid as well. So simply, drilling is creating a well, which is a hole in the earth to get a oil or get a gas mainly. But there are other reasons to drill a well as well. Maybe thermal energy, or you get hydrogen as we hear right now, or injecting CO2 as well. But mainly oil and gas companies, they drill wells for oil and gas or water injectors. These three main things. And there are completion as well. Once we finish drilling a well, we will leave a fluid in the completion stage in the well, and the main reason for that to prevent corrosion and does not damage the equipment you leave in the at the end of the well. And we will talk about completion fluid as well as filter cake breakers. I will go just in really short notes through these slides. as I divided into two sessions. Today we will know overview, and tomorrow we'll go more specific. So there are fluids used for throughout drilling, and once we finish drilling, there are completion fluid, and there are fluid to dissolve the filter cake, as we will learn later on at the end of the well. And when we leave the well, we will leave a backer fluid. So depends on drilling, which is land or onshore or offshore, you will have a service tree, or you have subsea service tree. Going to the drilling fluid. So what are the fluids? Maybe you learned this in thermodynamics about the fluids. And the fluids is a substance that flow. We can call anything fluid. Maybe people are working together in a large amount, we can call them a fluid. And water can be a fluid. Anything can be fluid. As this, if you like understand it very simply. But in drilling, there are like three types of fluid. You will have water base, and you have oil base as well, and you will have something called air fluid as well. But mainly we talk about water base and oil base, and we will talk about them deeply in this session as well. So fluids that's used for drilling, at the in the history, they started drilling wells with only water. So and very simple way to get the cutting of the well throughout water, just they pump water to the well, and the water will get out the cutting out of the well. But as much as the drilling got complex and complicated, the drilling fluid developed, and there are much more products, and they add additive to it to enhance this drilling fluid. But in fluid in general, we see the mechanism of the fluids. There are Newtonian fluids, and there are non-Newtonian fluids. And we can see in the chart on the right, you see them, they call it fluids or mud. It's the same thing. You will see the Newtonian fluid, you will have shear stress and shear strain are moving in the same direction, the same slope. But when you have non-Newtonian fluid like plastic or shear thinning or shear thickening, you will see a different behavior for this type of fluid. So here, a fluid that makes it possible that of drilling oil and gas wells, and it's very important overall success of the well construction. Here, very important thing is rheology, which is the study of and science of flowing matter. And rheology, it's very important, as discussed. The first reason for drilling fluids is removing cutting. So if you have a rheology, and maybe people mention it as a viscosity, good viscosity, you can carry the cutting. If you have very low viscosity like water, you cannot carry cutting if you have a deep well, or even shallow wells as well. So rheology it's just not just the viscosity, it's more than that, and we will discuss it more. You will have shear stress and shear stress as well, yield stress, and these are definitions. But if you look at them, they are definitions. But when you do mud engineering, it's important, because for example, the yield stress is the force required to initiate flow. So if you have a fluid in a well, and you require a very high force to initiate the flow for that fluid, means that's a wrong parameter. That means you will frack the formation because of that pressure. So this is things only definition, but in reality, it's very important as well. As the picture, you can see here the composition of the fluid. You see the big dark gray. It's the base of the fluid. In this case, it's water. So mainly you have a water base and oil base. And what we mean about water base and oil base, it means it's the main thing of the fluid. Then we have another chemical we add to it to add parameters, to enhance it and add characteristics to it. So we have a continuous phase. So for example, water, if you are like a cooking, so you put the water and then you put the tea and your milk. So your base is water, and that's are the additive to it. So continuous phase is water in some cases, and in some cases oil. And the discontinuous phases, the additive, are the other chemical adding to it. We can see the base fluid can be fresh water, seawater, or brine, and it can be diesel, saline. So these can be as a basis for the fluid. And the other things, the other chemicals can be solids, can be liquid, emulsifier, drill solids, gases, all that. Other than the base, they call it are additive to the fluid, or sometimes they call it contaminations if it's not desirable additive. Here the function of the drilling fluid, and this is maybe the most important slide here. We can see 11, let's see, you have a 4 on the top, 12, 13, 14. So you will have like almost 14 chemical you can add and change the characteristics of the fluid. And throughout this we will learn about the function of the drilling fluids. So we have density and weight. So we add chemical to increase the weight. And yeah, someone wanna talk? Okay, I will continue. So you have a chemical to add weight. You have a chemical to increase the viscosity. You have a chemical to filtrate control. So adding weight, increasing weight, adding viscosity, filtration control, controlling rheology, increasing pH, lubrication, fluctuation, shale stabilizer, as well as loss control chemical. You have a protection from corrosion. You have micro from the bacteria to kill a bacteria as well, and scale inhibition. So these all chemicals added to the drilling fluids. As we said, there are 3 types of the fluids. There is water base, non-aqueous, which is oil base, and you will have the air base or foam. And the last one is used for low density, very low density. So if we talk general about them, water base used mainly in the world because it's cheaper than oil base. And oil base is used for very high reactive shale to avoid stocks, and it's very expensive because the base of it's oil, and oil is already expensive. And the air, the main reason to use it's low density. This is the functions. We have 10 functions of drilling fluids, and this is the most important one, the control formation pressure. So you will have a range when you are drilling any formation, because the pressure of the formation, the earth, it's different, and it's required different density, and it's the main barrier when we are drilling. So the main barrier is mud weight, and the second barrier is BOP. So controlling formation pressure, first one. Then you have and this goes to from frag gradient to so you will have a range when you do controlling formation. You have the range. If you increase it, you will frag the formation, then you will have a losses, and maybe you get the differential stuck. And you will have a range. If you have low mud weight, you will have a kick. So you have to keep between these two. You have to drill between these two, and this is the most important one. Then you will have maintain wellbore stability. we discussed we have like 3 types of fluids. There is OBM. Why we need OBM? It's the main one to maintain well bore stability. As well, when you have a water base, you will have a chemical shell inhibition to do that. But that's meaning if you are drilling, for example, reactive shale, if you drill with water, it's well, that's mean that the density of it will increase, then your pipe will stuck. That's why you need water base. It will maintain your well bore stability. This is the second one. The third one, seal permeable formation. Permeable formation will cause you losses and will cause you stuck as well. So you will have a filtration control, very good filtration control. You will have like a blister in the well, like blistering a new house, you know, in like you have a blister, so you will have a very smooth wall of the well. That's mean it will not collapse. This is the third one. The fourth one, minimize formation damage. When we drill a reservoir, we have oil, we have a permeable formation, and we have drilling fluid ensure to maintain this this feature in the formation. So once you finish drilling, you will not damage the formation, you will not block these pores, and you will have a filter cake fluid to do that. The fifth one, cool and lubricate support for the bit, and it's good because the bit cannot move without the drilling fluid, and it helps cool it as well lubricate it. And there's a chemical added to the drilling fluid to lubricate throughout drilling, so increasing the torque. Number 6, transmit hydraulic energy to downhole tools. Without fluids, I don't know guys if you learn about MWD and logging, these tools will not work without drilling fluids. You have to pump fluid, so they will generate the data and transfer it to the surface. And as well as it helps these tools, same thing, to get the data for the well, like they will get gamma ray, resistivity, density, all these transits throughout the drilling fluid. Number 8, control corrosion. And because any metal will corrode, and wells, casing, and drill pipe are metal, so we add chemical to reduce the corrosiveness of these metals. Number 8, suspend and release cutting, which is hole cleaning. Very important. If you have a good parameter, your viscosity, your rheology is good, you will have a very good clean well. If they are off chart, that's mean you will have a problem accumulating this cutting. Number 10 is remove cutting as well from the well. We'll talk as well about solid control really quick. In the rig site, beside drilling fluid, you will have a shell shaker, which is in every rig. It's a must. Shell shaker runs throughout different screens to separate these drilling fluids. You will have hydro, cyclone, mud cleaner, centrifuge. Centrifuge is the lowest one. It's the he can get out the finest cutting. So if you want to separate cutting from the mud, centrifuge is the most. He can get the finest size. We talked about drilling fluids in the reservoir, as it will not damage the reservoir. We will have a filter. So once we finish drilling a reservoir, you will have a filter cake, and we run acid, and it will eat all the filter cake, and all the pores will open to produce from the well. Completion fluids. So once we finish drilling, we use completion fluid, and the completion fluid basically it's brine, and brine it's salt and water, these two things only. Why we need water? It's the base. Why we need salt? To have the required mud weight. and the characteristics of the completion fluid, it will not damage the formation because there is no solids on it. There is a completion fluid, and we talk about the brine, and then we will clean out the solution of the filter cake after drilling. Then we will put in the well backer fluid, that's corrosion inhibition. That's the backer fluids. It's the fluid will stay between the tubing and the casing. This is the presentation I prepared for you guys, and thank you very much for this half an hour. I hope it was very informative and short. Anyone have a question I can answer? No question, guys. We can finish this session if there is no questions.
There is a question in the chat. Can you see it?
In the chat?
Yes.
Okay, let's see. I will just finish sharing my screen. Okay. Okay, how could prevent losses at theft zone, fault hard zone? Can you explain? Because maybe the terminology is different, but what do you mean with the theft zone? This is from Ismail Musbih. أهلين إسماعيل. I don't know, but I will talk general about losses. Losses sometimes happen if you are drilling with a heavy mud. If your formation cannot handle the mud weight, so in that case you will have a losses. Also, you will have a losses. Yes, طبقات هشة. Okay, weak formation you mean? Okay. In this, when they design the well, they try to have all the theft zone in the same in one section and the hard zone in the other section, because if you do that it's gonna be difficult. But if it's in our case, if we drill the theft zone then the hard zone and it's manageable, you will try first to use the lowest mud weight you can use, so a mud weight will not get you a kick. So this is the first thing. Second thing, the bump rate should be the lowest, so you will not have a high ACD at the well. And you will use from the mud side, you will use strength material like calcium carbonate. This will close the pores in the theft zone. But the main one is you have to reduce the mud weight as minimum as you can, and the bump rate. From experience, LCM material will not be very useful in this case. السؤال من عبد الملك الجرداء كيف يؤثر طين الحفر على قراءات المجسات السلكية، وما هي المؤشرات التي تدل على أن هذه القراءات غير دقيقة؟ عبد الملك، وش تقصد بالمجسات السلكية؟ سامحني شوية لأنه نحن كله شغلنا بالإنجليش، فبالعربي ما نستخدم مجسات الآبار. وش قصدك بالMWD قصدك؟ مجسات الآبار، شو قصدك مجسات الآبار يعني؟ سليك لاين. هي مين سليك لاين؟ سليك لاين نحن رج اوبريشن. سليك لاين هذا يجي في رجلس، فما عندي صراحة اكسبيرينس فيه. بس if you mean logging، اللوجينج يتم بالمد. الداتا تنتقل من from the tools to the surface through the mud. So and he cannot run his tools without mud. So يعني example معك إذا كان المد مثلا في for example very foam, so the brusher will play. يعني brusher ما بيكون ثابت, he cannot read, the tools cannot be logging, he cannot يعني بتسوي logging. This is the one case. If the mud has a foam and the brusher is يعني moving in, يعني يتحرك كثير, يطلع وينزل, فما يقدر. فهو قراءاته كلها بالمد. هذا جواب سؤالك. العفو. في سؤال ثاني شباب؟ أعتقد ما في سؤال. شكرا كثير. Thank you all for your time. I hope ماذا يعني ما تؤثر طين الحفر على قياسات الكاليبر؟ ما تؤثر على قياسات الكاليبر. لا, قصدك لما يكون الكاليبر if the well is يعني if you have a washout in the well, لا ما تؤثر على قياسات الكاليبر. هذا from my information, بس I'm not MWD specialist, I'm not logging specialist يعني, فيمكن they have another شو اسمه حاجة, لكن from my side I don't think so. I don't think so. باسم ما أعتقد, يعني ما أعتقد. Any other question, guys?
Thank you for your time, Ustad. We are grateful to you.
Okay, thank you very much, guys. I hope you guys enjoy this session, and see you tomorrow for another session. Thank you very much.